So the experiment I did was the equilibrium between cobalt 2 chloride solution. What I did was I dissolved 4 grams of solid cobalt 2 hexahydrate in 40 milliliters of water. As you can see, my calculations, well, my weight is pretty on point. I added 60 milliliters of hydrochloric acid to the beaker with the water and cobalt. And then the reaction / balance equation was COH2O6 plus 4HCl produces COCl4 plus 6H2O. So then I disrupted the equilibrium from the base by adding heat and adding ice. So our forward reaction, I added heat, which increased the concentration of chlorine ions and caused a color change from the equilibrium solution. So as you can see, the color became a darker pink, and the heat moved towards the CO and HCl molecules. So that's why we see a color change. And this is an endothermic reaction. As you can tell by the graph, our reactants are our COH2O6 plus the 4Cl. So when we added the heat, it produced the COCl4 plus 6H2O. So yeah, and then the reverse reaction, I put a sample of the base into the ice, which caused the color to change a lighter pink, as you can see here. Heat is released from the CO and Cl molecule and HCl molecules, so that's why we see a lighter change in color, and that is why our graph looks like it's an exothermic reaction, because heat is being released. So just to wrap it up, what was the difference about the forward and reverse reactions? The forward reaction, by adding HCl, we increase the concentration in chloride ions, which then creates the COCl4. And in the reverse reaction, when we add water, the equilibrium shifts to the left, which creates COH2O6. So the most common change, as you can see, was the change in colors from the forward and the reverse reaction. And in the forward reaction, by adding heat, you shift it forward, and by adding ice, you shift it backwards. So yeah, that was my experiment.